cube plus xy square plus x square dx plus x square y dy is equal to, if you multiply x and 0, right hand side becomes 0. So this is an exact differential equation. Okay. Now you know how to find out the general solution. So general solution is given by, write down your first function as it is, that is x cube plus xy square plus x square. Integrate this function with respect to x, treating y constant, plus. Now from the second term, select only those terms which are free from x. Now here your second term contains x square into y. Okay, there is only one term and this term contains x. So required term is 0 only, 0 dy. We want only those terms which are free from x. Okay, so there is only one term x square into y. So this term contains x. So we required term is 0 dy and add integrating constant. So simplifying, we get our general solution. Okay. So integration of first term, you can write down separately x cube dx, y square is a constant, integration of x dx plus integration of x square d. Integration with respect to x, y is a constant. What is integration of 0 dy? Integration of 0 is integration of 0. Yes, integration of 0 is 0. Correct. Right hand side constant is c. So integration of x raised to 3. So it's x raised to 4 divided by 4 y square. Integration of x is x square divided by 2. Integration of x square is x cube divided by 3 is equal to c. So here everywhere I am using this formula only. Integration of x raised to n dx is x raised to n plus 1 upon n plus 1. So using this formula here we get value of integration. Okay. So to solve non-exact differential equation using suitable rule, find out first integrating factor, multiply your differential equation by an integrating factor and find out corresponding exact differential equation. And by using our standard formula, find out our general solution. Okay. Understood everyone? Any doubt in this example?
No, ma'am.
So next example. Solve 2x square y square plus e raised to xy dx is equal to e raised to x plus y cube dy. 2x square y square plus e raised to xy into dx is equal to e raised to x plus y cube dy. Okay, our standard steps. First step, write down your given differential equation in standard form. Standard form is m dx plus n dy is equal to 0. We want our right hand side as 0. So first make right hand side 0. So 2x square y square plus e raised to x into dx minus e raised to x plus y cube dy is equal to 0. Okay. Write down your differential equation in standard form. Standard form is m dx plus n dy is equal to 0. Now carefully write down your m and n. The term along with dx is nothing but your m. So here m is equal to 2x square y square plus e raised to xy. Okay. Can you tell me what is n? Carefully write down your n. Anyone? What is n here?
Minus e to the power x plus y cube.
Correct. So here if you write down only e raised to x plus y cube, it's wrong. Your sign is minus. So carefully write down your n. Outside there is a minus sign. So it's minus e raised to x plus into minus is minus y cube. So first step is very important. Carefully write down your m and n. Next standard step, differentiate your m with respect to y. So differentiation with respect to y means x is a constant. So by 2x square term constant as it is, derivative of y square is 2y. Plus with respect to y means e raised to x is constant. Derivative of y with respect to y is 1. So my del m by del y is 4x square y plus e raised to x. Okay. Now differentiate your n with respect to x. So minus as it is, derivative of e raised to x is e raised to x minus second term is y cube only. There is no x. I want derivative of n with respect to x. With respect to x, y is a constant. So y cube, there is no x, constant term, derivative is 0. So del n by del x is minus e raised to x. Next step, compare these two derivatives. Del m by del y and del n by del x. Just compare these two derivatives. So del m by del y is 4x square y plus e raised to x and del n by del x is simply minus e raised to x. So here we get different derivatives. So conclusion is given differential equation is not exact. Given differential equation is not exact. Since it is not exact, we want integrating factor. We want corresponding exact differential equation. So how to find out exact differential equation? So next step is find out integrating factor by using suitable rule. Okay, so you know 4 rules. So tell me, just see your differential equation and tell me, can we apply rule number 1 or rule number 2 or rule number 3? Step 1. Just see your differential equation. Can we apply rule number 1?
No, ma'am.
Because this is not a homo. Whenever your differential equation contains exponential function, trigonometric function, it's not homogeneous. Okay. So you cannot apply rule number 1. Can we apply rule number 2?
No,
See
ma'am.
your equation.
No.
No. So we cannot apply rule number 2 also. From first term, you can take y common. Okay. There is a confusion. If you take y common, yes, here we get y into dx. Remaining part is 2x square y plus e raised to x. Okay, if you take y dx. But from the second term, you cannot take x common. E raised to x plus y cube dy. To apply second rule, here we want y dx and here we want x dy. Okay, so we cannot apply rule number 2 also. So find out del m by del y minus del n by del x. Del m by del y minus del n by del x divided by n. Just simplify. After simplifying, if it is a function of x only, then you can apply rule number 3. So what is del m by del y? It's 4x square y plus e raised to x minus del n by del x is minus. So minus minus becomes plus e raised to x divided by n. So what is n? Minus e raised to x minus y cube. Okay. So you can simplify this as 4x square y plus 2 e raised to x divided by minus e raised to x minus y cube. So after simplifying this term, del m by del y minus del n by del x upon n, here you can see combination of x and y. So here this is not only function of x. Compare with previous example. In previous example, after simplifying del m by del y minus del n by del x upon n, we get a function of x only. So here we get 1 upon x. Okay, since it is a function of x, you can apply rule number 3. But for second example, after simplifying del f by del y minus del n by del x upon n, we get a function of x as well as y. So rule number 3 is not applicable. Okay, so try for rule number 4. So del n by del x minus del m by del y divided by m. Find out this expression. Okay, so what is del n by del x? Minus e raised to x. Del n by del x is only minus e raised to x. And del m by del y is 4x square y plus e raised to x. Sign is minus. So minus 4x square y minus e raised to x divided by m. What is m? 2x square y square plus e raised to xy. 2x square y square plus e raised to xy. Just replace values of derivatives and m and simplify. So minus e raised to x minus e raised to x, it becomes minus 2 e raised to x minus 4x square y divided by 2x square y square plus e raised to xy. Initially, you can see it's a combination of x and y, but simplify. From numerator, you can take minus 2 common. So remaining part is e raised to x plus, because minus 2 is common, remaining part is 2x square y. From denominator, you can take y common. So 2x square y, 1y is common, plus e raised to x. Okay. So e raised to x plus 2x square y is a numerator divided by 2x square y plus e raised to x. 1 plus 2 is same as 2 plus 1. So after simplifying, we get minus 2 by y. Function of y only. If you simplify up to this, here you can see combination of x and y. You have to simplify further. Take common part, and then finally after simplifying we get function of y only. So yes, since it is a function of y only, we can apply rule number 4. So integrating factor is e raised to integration of f of y dy. Integrating factor is not minus 2 by y. You have to, since it is a function of y, you have to find out the integrating factor by using this formula. So just remember the standard steps. E raised to integration of minus 2 by y dy. So e raised to minus 2 is constant, integration of dy upon y. You know that integration of 1 upon x is log x. Instead of x, my variable is y. So here integration is e raised to minus 2. Integration of 1 upon y is log y. Now very important properties. E raised to log a is a only. Okay, we have used this in previous example. Now, what is e raised to b log a? You can simplify by using properties of log. It's a as e raised to log a raised to b. Simplify. And then by using previous property, it's a raised to b only. I'm using this property b log a. B log a is same as log of a raised to b. Okay, so b log a is e raised to log a raised to b. And we know that e raised to log is a raised to b only. So by using this property, you can simplify this as e raised to log y raised to minus 2. Okay, so e raised to log y raised to minus 2 is same as y raised to minus 2. Y raised to minus 2 means 1 upon y square. So just by using these properties of log, okay, remember these properties of log, very, very important. Okay, so my integrating factor is 1 upon y square. So just multiply your differential equation by 1 upon y square. So write down your differential equation as it is 2x square y square, 2x square y square plus e raised to xy dx minus e raised to x plus y cube dy is equal to 0. Original differential equation which is not exact. Okay. Multiply your differential equation by an integrating factor. So multiply each term by 1 upon y square. So 2x square y square upon y square. So my first term is 2x square only. Plus e raised to x, y upon y square is y into dx, e raised to x divided by y square, y cube upon y square is y dy. Okay, this is exact differential equation. Original differential equation is not exact. So find out integrating factor by using suitable rule. Okay, so using here rule number 4 is applicable. E raised to integration of f of y dy is integrating factor. So just multiply your differential equation by an integrating factor. You have to remember the standard steps. Cover all steps till we get our final solution. Now this is just the exact differential equation. We want its solution. So general solution. First term as it is 2x square plus e raised to x divided by y dx, treating y constant, okay, plus. Now from the second term, tell me, select only those terms which are free from x. Can you tell me the corresponding terms? Anyone?
1 by y square plus y.
1 by y square plus y. Okay, anyone? So 1 by y square plus y is the correct answer. Remaining students. What is rule? Rule is from the second term. Select only those terms which are free from x. Okay. So
Sorry,
here
y,
you can
y.
y. Okay. Here you can see two terms. Okay. First term is e raised to x plus y square. This is your first term. And second term is y. Now first term is e raised to x divided by y square. So this whole term contains x, but we want the terms which are free from x, so you cannot select first term. If you select 1 upon y square, what about e raised to x? This is only one term. whose numerator is e raised to x and denominator is y square. Okay, so you have to consider the whole term. This first term contains x, e raised to x. So you cannot take first term. Second term, there is a y only. There is no x. So yes, you can select the second term because the second term, whole term, there is a no x. Okay, but you can see the sign outside, there is a minus sign. So corresponding term is minus y dy is equal to integrating constant. This step is very, very important. You have to select only those terms which are free from x. Here n contains only addition of two terms. First term e raised to x upon y square. So numerator is a function of x. So you cannot select your first term. Second term, yes, it is a totally free from x. There is a y only. Now find out the integration. So 2 integration, 2 is a constant, integration of x square dx. Y is a constant, so 1 upon y is constant, integration of e raised to x dx. Minus is a constant, integration of y dy is equal to c. Now tell me the integration. Integration of x square, be active.
X cube by 3.
Correct, it's x cube by 3. 1 upon y, integration of e raised to x.
E raised to x.
Correct. Integration of y.
Y square by 2.
Correct. Y square by 2 is equal to C. So this is your final solution. Okay. So you can apply now any rule. Whether it is exact or non-exact, now you can solve any differential equation. Okay. If it is exact, use this formula. But if your differential equation is not exact, using suitable rule. Rule number 1, 2, 3, 4. Find out integrating suitable integrating factor. Once you find out your integrating factor, next step is multiply your given differential equation, which is not exact, by an integrating factor and write down corresponding exact differential equation. And once you write down your exact differential equation, again by using general formula, find out general solution. And this step is very, very important. Terms of n which are free from x. Select only those terms which are free from x. If there is x, delete the corresponding term. If all terms contain x, then write down as a 0 dy. Understood everyone how to solve exact as well as non-exact differential equation? Any doubt? Next party, so for the exam, you have to revise exact differential equation and solution of non-exact differential equation by using these four rules. Okay. Now, next topic is linear differential equation. Linear ordinary differential equation. So I'm just writing the standard form. For exact, you have to compare your differential equation with m dx plus n dy is equal to 0. For linear ordinary differential equation, okay, two types. So first type is linear in y. So standard form is dy by dx plus py is equal to q. Okay, where p and q are functions of x or constant. Functions of x or constants. Okay. So say your differential equation. Differential equation is dy by dx plus py is equal to q. So coefficient of dy by dx is 1 here. Okay. And p and q, there is only one y. Along with y, there is a p. P is either constant or function of x. Right hand side is a q. Is again it is a constant or function of x. So in your differential equation, there is only one y. So this is linear in y. And second type is linear in x. So linear in x means dx by dy plus px is equal to q. So see your differential equation. Differential equation contains only one x, where p and q are functions of y, are functions of y or constants. So two types of linear differential equation. dy by dx plus py is equal to q and dx by dy plus px is equal to q. Okay. Differential equation containing only one y is linear in y. Differential equation which contains only one x, remaining are either constants or functions of y, is linear in x. Okay. If your differential equation is linear, how to find out its solution? Okay, so for linear differential equation, so to find a general solution, find general solution. Okay. Suppose my differential equation is linear in y, dy by dx plus py is equal to q. Okay. Differential equation is linear in y. So if your differential equation is linear in y, then integrating factor is e raised to integration of p, okay, dx. Derivative is with respect to x, dy by dx. So integrate with respect to x. Okay. And general solution, since it is linear in y, suppose I denote integrating factor by I. So yi is equal to integration of qi dx plus c. Okay. So this is the solution of linear differential equation in y. Suppose differential equation is linear in x. So dx by dy plus px is equal to q. Okay. So in this case, integrating factor is same, e raised to integration of p. For linear in x as well as linear in y, your integrating factor is e raised to integration of p. But with respect to x or with respect to y, so for that you have to see the differentiation. Your differentiation here is with respect to x. With respect to x, so therefore integration is with respect to x. Here derivative is with respect to y. So my integrating factor is e raised to integration of p dy. Okay, normally यहाँ पे आपका confusion होता है with respect to x or with respect to y. Derivative is with respect to x, so integration with respect to x. Here derivative is with respect to y, so integration is with respect to y. So this is my integrating factor and general solution. Suppose integrating factor is I. General solution is given by. Now, previous one is a difference linear in y. So since it is linear in y, your general solution is y into I. Because y into I, why? Because this is linear in y. So my general solution is by I is equal to. Now my differential equation is linear in x. Okay, my second equation is linear in x. So my general solution is x into I. So remember this formula, xi is equal to remaining terms are same. q into integrating factor. Integration is with respect to y plus second type of differential equation. Okay. Just remember this. You have to remember the steps only with respect to x or with respect to y. Second one is linear in x. So your left hand side is x into I. First one is linear in y. So my general solution is y into I. Okay, and to integration is with respect to x or with respect to y depends on your differentiation. First differentiation with respect to x, so integrate with respect to x. Second one, differentiation dx by dy with respect to y, so integration is with respect to y. So carefully find out your integrating factor and then you can write down your general solution. Okay. So this is method to find out solution of linear differential equation. Okay. Just remember these steps. So first example. Solve the differential equation dy by dx plus 1 upon xy is equal to sec square x divided by x. Dy by dx plus 1 upon xy is equal to sec square x upon x. Okay. So problem is just solve this differential equation. Here it is not mentioned. This is exact, non-exact, linear or reducible to linear. So what is hint here? You can compare, see your previous examples. Okay. Previous example. So today's first example. Solve the differential equation x square plus y square plus x dx plus xy dy is equal to 0. So here right hand side is 0. You can see only two terms. Okay, x square plus y square plus x dx plus second term is xy dy. So in this differential equation, there are only two terms. So you can compare with m dx plus n dy is equal to 0 and solve by using either exact or non-exact differential equation. Today's second example. Again, 2x square y square plus e raised to xy into dx. This is your first term. Right hand side e raised to x plus y cube dy. Second term dx and dy. Okay. So compare with m dx plus n dy is equal to 0. Only two terms. Only two terms. So hint is solve by using exact or non-exact differential equation. Now see this example. Dy by dx plus 1 upon xy. So first term is dy by dx, second term is 1 upon xy, and there is a one more term, x square x upon x. So this differential equation contains three terms. Okay, so you cannot write down, you can write down in m dx plus n dy is equal to 0 and solve by using exact, but it's easy here to solve by using linear. You can check this differential equation contains only one y, dy by dx plus some function of x into y. Right hand side is a function of x only. So here you can see directly, yes, it is a linear differential equation in y. So no need to write down in the form m dx plus n dy is equal to 0. You can directly compare with dy by dx plus py is equal to q. So solution, it's a hint. Normally, differential equation with only two terms solved by using exact or non-exact. Addition of three terms. Left hand side is addition of two terms. Right hand side there is a third term. So solve by using linear. Here you can easily see it's a linear in y. So given differential equation is linear in y. So compare with standard form. Again write down your standard form. Dy by dx plus py is equal to q. Compare your differential equation with standard form. So by comparing, we get p is equal to 1 upon x and q is equal to right hand side function of x, that is sec square x divided by x. Okay. So already you can see in standard form coefficient of dy by dx is 1, and in given differential equation coefficient of dy by dx is also 1. If it is not 1, then make it as 1. Divide throughout by coefficient of dy by dx. So already given differential equation is given in standard form. So you can directly write down values of p and q. Then integrating factor is always e raised to integration of p with respect to x or with respect to y. Differentiation is with respect to x. So integration is also with respect to x. So this is the formula. Just replace value of p, that is 1 upon x dx. Okay. So now again I am using same formula. What is integration of 1 upon x?
Log X.
Correct.
Log
It's
x.
log x. And what is e raised to log x? By using
X.
properties of
X.
log is x only. So my integrating factor is x only. Okay. Now this is linear. So you can directly write down your general solution. In exact differential equation, we actually multiply our differential equation by an integrating factor. But in linear differential equation, you can write down your general solution. Just find out integrating factor and write down general solution. Now, what is formula to write down the general solution? Since it is linear in y, my general solution is y into I. Integrating factor is I. If your differential equation is linear in x, your general solution is x into I. Since it is linear in y into I, integration of q into I, integration is with respect to x plus. First, write down carefully your formula. Linear in y, so y into I is equal to integration of q into I dx plus c. So write down all values. Integrating factor is x. Q means right hand side function is sec square x upon x. Integrating factor is x dx plus c. No simplification for left hand side. So left hand side remains as it is. Yx is equal to x upon x is 1. It's simply sec square x dx plus c. What is integration of sec square x?
Tan x.
Correct. Derivative of tan x is sec square x. So integration is nothing but antiderivative. So integration of sec square is tan x. So just revise basic integration results. Yx is equal to tan x plus c. So this is my final solution. Solution of given linear differential equation. Okay. Already differential equation is given in standard form. So compare with dy by dx plus py is equal to q. Write down carefully your p and q. Luckily your coefficient of dy by dx is 1. So you can directly write down p and q. Find out integrating factor and general solution. Integrating factor is e raised to integration of p dx, and general solution, since it is linear in y into I is equal to integration of q into I dx plus c. So using this we get our final solution. Let's solve one more example and then we'll start our unit number 2. So second example. Solve the differential equation dy by dx plus 2xy is equal to 2 e raised to minus x square. So I am giving you 2 minutes. Find out integrating. First tell me how to solve this differential equation by using exact or by using linear differential equation. Yes, Aditya?
Ma'am, by linear.
Yes. Already differential equation is given in standard form. There is only one y. So this differential equation is linear in y. Okay. So try to solve by using linear differential equation in y. Write down values of p and q. Solution. I am directly writing because already it is in standard form. P is 2x and q is 2e raised to minus x square. Integrating factor e raised to integration of p dx. Write down carefully your formula. So e raised to integration of 2x dx. And try to write down your general solution. First, tell me what is your integrating factor. You can write down in chat box. Integrating factor.
E raised to power x square.
E raised to power x square. Correct. So e raised to 2. Integration of x is x square by 2. So it's simply e raised to x square. It is linear. So you can directly write down the general solution. So general solution. Since it is linear in y, general solution starts with y. Y into integrating factor is integration of q into I dx plus c. So this is the formula. So y integrating factor is e raised to x square. Q is 2e raised to minus x square. R is e raised to x square dx plus c. So you cannot simplify your left hand side. Left hand side remains as it is. 2 is a constant. E raised to minus x square into e raised to x square dx plus c. What is e raised to a into e raised to b? Since base is same, just add your indices e raised to a plus b since base is same. And what is value of e raised to 0? Any non-zero number raised to 0 is always 1. So simplify and tell me what is right hand side by using these properties. So y e raised to x square is 2. E raised to minus x square, e raised to x square. So base is same. So minus x square plus x square. So minus x square plus x square is 0. Any non-zero number raised to 0 is always 1. Integration of
Is
dx
equals
plus
to
c.
2.
So what is integration of dx?
X.
Integration of 0 dx is 0. Integration of dx is x. Okay. So 2x plus y e raised to x square. So this is your final solution of the given differential equation. Okay. So just first step is very important. How to solve the differential equation by using exact, non-exact or by using linear. Okay, so linear means differential equation containing three terms. Hint, it's a hint. Three terms, addition of three terms. Then linear. And of the type m dx plus n dy is equal to 0, addition of two terms, exact or non-exact. So again, I am repeating unit number 1, then start our unit number 2. Okay, so two types, m dx plus n dy is equal to 0, and second type dy by dx plus py is equal to q. Similarly, you can write down linear in x also. Okay, so to solve first type of differential equation, okay, two terms means exact. So find out del m by del y and del n by del x, and if both derivatives are equal, implies you have to find out the solution by using exact differential equation. First case. Second case, if we get different values, del m by del y is not equal to del n by del x. So my conclusion is differential equation is not exact. Okay. If it is not exact, find integrating factor using suitable rule. And once you find out your integrating factor, find out, hence find exact differential equation. How to find out exact, multiply your non-exact differential equation by an integrating factor and find out your exact differential equation. Once your differential equation is exact, find your general solution by using formula. Okay. Integration of m dx stating y constant. Integration from n, select only those terms which are free from x. Find out your general solution. And here, this is a linear differential equation. Okay, so find out directly your integrating factor. Integrating factor is always e raised to integration of p. Derivative is with respect to x, so integration is with respect to x. This is your integrating factor. In exact differential equation, we multiply your differential equation by an integrating factor. But in linear, no need to multiply. You can directly write down your general solution. General solution is, since linear in y, by I is equal to integration of qi dx plus. Similarly, linear differential equation in x. Either it is linear in y or linear in x. So next type is dx by dy plus px is equal to q. Either it is linear in x or linear in y. Linear differential equation. And first one is exact or non-exact differential equation. Now you can solve. So for this exam, we have included exact differential equation, non-exact differential equation using first four rules. Find out the solution if it is not exact. And for linear differential equation, either it is linear in x or linear in y, only this part. Next topic is non-linear differential equations reducible to linear form. This topic is not included for this remedial exam, up to linear differential equation only. Okay, this is about unit number 1. Any doubt in unit number 1? No need to cover whole unit. Okay, just revise exact, non-exact, first four rules only. No need to solve example using rule number 5. First four rules, homogeneous, second type, rule number 3 and rule number 4. First four rules, and for linear, linear in x or linear in y only. Now, unit number 2, applications of ordinary differential equations. Applications of ordinary differential equations. Now again, we have included only three applications. Newton's law of cooling, second, electric circuit, and third, mixing problems. Okay, you have to revise only these three applications only. No need to cover rectilinear motion, orthogonal trajectories, or heat flow. Out of six, we have included only these three applications. So revise properly these three applications. Okay, so I'm directly starting the examples on Newton's law of cooling, electric circuits, and mixing problems. So let's revise first what is Newton's law of cooling. So Newton's law of cooling states that the rate of change of temperature of a body is proportional to the difference between the temperature of the body and surrounding medium. So this is the statement of Newton's law of cooling. Okay, suppose your body temperature is theta. Theta denotes the temperature of the body at time t. So T denotes time. Theta denotes temperature and T denotes time. Temperature of the body at any time T. Rate of change of temperature means differentiation. d theta by dt. So your temperature is changing according to time. So d theta by dt, this is the rate of change of temperature. Temperature changes as time. So d theta by dt, rate of change of temperature. What is Newton's law of cooling? It states that rate of change of temperature of a body is a proportional to the difference between the temperature of the body. So temperature of the body notation is theta and surrounding temperature. So our notation is theta 0 for surrounding temperature. Theta minus theta 0. Rate of change of temperature of a body. So d theta by dt is directly proportional to difference between temperature of the body and surrounding temperature. So d theta by dt is proportional to theta minus theta 0. So you can write down as equality d theta by dt is equal to theta minus theta 0 and multiply by proportionality constant K. This is a process of cooling. Okay, so your temperature decreases. Since temperature decreases, your sign is minus. So using this differential equation, you can solve any example based on Newton's law of cooling. No need to remember this, that is d theta by dt is directly proportional to theta minus theta 0. Just remember this differential equation. D theta by dt is equal to minus k theta minus theta 0. Theta denotes temperature, T denotes time, theta 0 denotes surrounding temperature. So this is your differential equation. Okay, to solve any example, just remember this differential equation, and solution is also constant. So how to solve this differential equation? So using variable separable form. So solution is also constant. So d theta divided by theta minus theta 0 is equal to minus k dt. And integrating, we get our solution. So this is 1 upon theta is nothing but log of theta minus theta 0 is equal to minus k. Integration of dt is t plus c. So this is the solution of difference. You can directly remember this too. Newton's law of cooling. So write down this differential equation. D theta by dt is minus k theta minus theta 0. And its solution is log of theta minus theta 0 is equal to minus kt plus c. Okay, so using this differential equation and its solution, you can solve problems based on Newton's law of cooling. So let's solve one example. So write down this example. Write down this example. A metal ball is heated to a temperature of 100 degrees Celsius, and at time t is equal to 0, it is placed in water which is maintained at 40 degrees Celsius. If the temperature of the ball is reduced to 60 degrees Celsius in 4 minutes, find the time at which the temperature of the ball is 50 degrees Celsius. So first carefully write down your problem statement. Okay, I am giving you 1 minute. Okay. To solve the problem based on Newton's law of cooling, first prepare a table. Okay. So theta, what is theta? Theta is the temperature and t denotes time. So first prepare the table. A metal ball is heated to a temperature of 100 degrees Celsius. So initial temperature of the ball is 100 degrees Celsius. Initially here given that at time t is equal to 0, but if it is not given, always take initial time as 0. So initially a metal ball is heated to a temperature of 100 degrees Celsius. So my temperature is 100 degree and initial time is 0. It is placed in a water. Okay, so surrounding is of water which is maintained at 40 degrees Celsius. So 40 degrees Celsius is the surrounding temperature because metal ball is placed in water. So theta 0, surrounding temperature is given as 40 degrees Celsius. Carefully prepare your table. Read your problem 2 to 3 times and prepare your table properly. My theta 0 surrounding temperature is 40 because metal ball is heated and it is placed in water. So water is the surrounding medium whose temperature is 40. So according to our notation, theta 0 is 40 degrees Celsius. If the temperature of the ball is reduced to 60 degrees Celsius, so my temperature of the ball is 60 degrees Celsius in 4 minutes. So T is equal to 4. In 4 minutes, temperature of the ball reduces to 60 degrees Celsius. It is given. Find the time. So I want third entry in second column at which the temperature of the ball is 50 degrees Celsius. Okay. So this is given. Read your problem 2 to 3 times and carefully prepare your table. Initial temperature of the ball, so whenever it is T is equal to 0, 100 degrees Celsius, initial temperature. Any doubt? Let me check the chat box. Okay, in problem it is given in terms of minutes. Okay, so take time in minutes. If it is given in seconds, then take T in terms of seconds everywhere. Here given that time is given in terms of minutes. So take T as 0, T as 4, and find the time at which the temperature of the ball is 50. So we get our solution in terms of minutes only. Okay. So prepare your table. This is very, very important. Now, so what is differential equation? So my differential equation is, according to Newton's law of cooling, d theta by dt is equal to minus k theta minus theta 0. Okay, and by using variable separable form, okay, by using variable separable form, you can directly write down your solution as log of theta minus theta 0 is equal to minus kt plus c. Okay. So using this equation, you will get your solution. So remember this differential equation as well as its solution to solve problems based on Newton's law of cooling. Okay. Now use your first condition. My first condition is when T is equal to 0, theta is equal to 100. So this is your original equation. Now put T is equal to 0, initial condition, and theta is equal to 100 and theta 0 is equal to 40, surrounding temperature. So use first condition, you will get some value. So log of theta is equal to 100, theta 0 is equal to 40, k is not given, t is 0, and c. So using first condition, 100 minus 40 is 60, k into 0 is 0, so my c is log 60. Okay, so using first condition, initial temperature and initial time, we get value of c. Now use your second condition. What is second condition? T is equal to 4, theta is equal to 60. So put T is equal to 4, theta is equal to 60, and theta 0 is equal to 40. Okay, so use same equation. So log of theta is 60, theta 0 is 40, minus T is 4, K is a constant, and your value of C is log of 60. So just replace values of theta, theta 0, value of C. Okay. Now using second condition, we simplify, we get value of K. So log of 60 minus 40 is 20. So simplification of left hand side is log of 20 minus 4K plus log of 60. So 4K is equal to log of 60 minus log of 20. Okay. Now very, very important property of log. Log of A minus log of B is log of A by B. It's not log of A minus B. It's log of A by B. So by using this property, we get 4k is equal to log of 60 by 20 by using properties of log. So 4k is equal to log of 3. So using second condition, we get value of k log 3 divided by 4. Okay. So this is a Newton's law of cooling. Remember this differential equation and its solution. You can solve all examples by using this formula only. Okay. So your table is ready. Use first condition. T is equal to 0, theta is equal to 100. So T is equal to 0, theta is equal to 100 and surrounding temperature theta 0 is equal to 40. Okay. Simplify in the replace in this equation and simplify. We get value of C. C is log 60. Now use your second condition. Theta is equal to 60, T is equal to 4 in same equation. So using T4, theta 60, theta 0, 40 and using condition 1, you know the value of C also. So replace all values in this original equation. And simplifying by using properties of log, we get value of K. Okay, so now we have C as well as K. So my this equation star becomes log of theta 0 is 40 is equal to minus K. So K is log 3 divided by 4T and C is log 60. So this is your final solution. Okay, you can find out it. You can find out T or theta by using. This is your solution by using Newton's law of cooling. Okay, you can solve any example by using this method. Carefully prepare your table, write down your differential equation and this solution. Use first condition, find out C. Use second condition, use properly properties of log, find out your K and just replace your values of C and K in original equation. Already you know this is the solution. So replace values of C and K. So this is my final solution. You can solve any example by using this method. Now see your given problem. Third column. We want value of time when theta is equal to 50. So in your final step, replace theta is equal to 50. Okay. So put theta is equal to 50. So log of 50 minus 40 is minus log 3 divided by 4t plus log 60. Okay. So here we get log of 50 minus 40 is 10 minus log of 3 divided by 4 into t plus log 60. So on left hand side it becomes log 3 divided by 4t is equal to log of 60 minus log of 10. Now, using properties of log, tell me what is log 60 minus log 10.
Log 60 by 10.
Correct. Log of A minus log B is log of A by B. It's not log of 50. Okay. Use properly properties of log. So it's log 6 only. Okay. Log 6. So log 3 t divided by 4. But we want value of t only. So it's log 6 into 4 divided by log 3. Now, by using calculator, find out log 6 into 4 divided by log 3. So here base is natural. So to find out its solution, by using calci, log of 6 means find out ln 6. Using calculator, ln 6 multiply by 4 divided by ln 3. Using calculator, and tell me what is the final solution. Share your final solution. Let me check how many of you are active. Yes, you have to use the calculator. Remaining students, share your solution. Correct. It's 6.52. Correct. So this is your final solution. Okay. So to solve problems based on Newton's law of cooling, read your problem 2 to 3 times and carefully prepare your table. Write down surrounding temperature, initial time 0, initial temperature. Then after 4 minutes, so when T is equal to 4, your reduced temperature. Here problem is find out time. Theta is given. Sometimes T is given, find out temperature. Conversely. So to solve any type of example, remember, this is your differential equation d theta by dt, and this is your final solution. Okay. Use first condition, find out C. Use second condition, find out K. Okay. And once you know the values of theta, C and K, again using same differential equation, replace your values of C and K and write down your general solution. So this is my general solution. Here theta is given, so replace theta. If T is given, replace T and find out theta. Simplify and finally find out your solution by using calculator. Use ln, log to the base e. ln 6 into 4 divided by ln 3. Okay. एग्जाम में ऐसे भी आ सकता है. टर्म टाइम इज गिवन, सो फाइंड आउट टेम्परेचर ऑफ द बॉल आफ्टर 6 minutes. Okay, so in this case, take T is equal to 6, simplify and find out corresponding temperature. Understood everyone how to solve problems based on Newton's law of cooling? Okay, so second application. So this is over for Newton's law of cooling. D theta by dt is equal to minus K theta minus theta 0, and general solution is log of theta minus theta 0 is equal to minus kt plus c. Just remember this, and using your table, find out C and K. Now second application is electric circuits. So three types of electric circuits. Okay, I am going to take example based on only one type. Let's revise first. Electric circuits. So already you are familiar with this notation. L denotes inductance, R denotes resistance, C denotes capacitance, E is electromotive force or voltage, Q denotes charge, and I denotes current. Relation between current and charge is I is dq by dt. Okay, or Q is integration of I dt. Voltage drop across resistance is Ri. Voltage drop across inductance is L di by dt, and voltage drop across capacitance is Q by C. Okay, already you are familiar with this. Suppose your problem, your electric circuit contains L and R with electromotive force, voltage E. So voltage drop across L is L di by dt. So my differential equation is L di by dt, across resistance is Ri, okay, is equal to E. So voltage, if your electric circuit contains L and R, so you know along L it's L di by dt, along R is Ri. So total voltage drop is L di by dt plus Ri is equal to E. So if your problem contains a circuit, which circuit containing L and R, use this differential equation. which is linear in I, and solve your solution. If your electric circuit contains L and C, okay, so voltage drop across L is L di by dt, so it's L di by dt. Across C, it's Q by C, so it's Q by C is equal to electromotive force is E, but it's after removing source applied EMF, so voltage is zero. In this case, take it as zero. If it is E, take it as E. Third type of circuit, so LCR. So here you get three combination, either LR, LC or RC. So along R it's RI, voltage drop across R is Ri, across capacitance is Q by C and is E. So this is not a differential equation. Okay, what is differential equation? Any equation which contains a derivative. So you have a derivative in नहीं दिख रहा है. Then how to solve this? So by using relation between I and Q. Okay, I is nothing but dq by dt. So here we get a differential equation. Okay, so read your problem statement carefully. Okay, if your electric circuit contains L and R, so here you have to write down this differential equation and solve. This is linear in I. If your problem contains circuit containing L and C, so just write down this differential equation, find out your solution. And third type, differential circuit containing R and C. So this is your differential equation which is linear in Q. Okay, so three types of circuits today. So read your problem statement carefully, write down suitable differential equation and find out its solution. All are linear. So you have to find out the solution of electric circuit using linear differential equation. Okay. So today I'm going to cover only one circuit. Similarly, you can solve the remaining circuit problems. So write down first problem statement. So write down problem. A resistance of 100 ohms and inductance of 0.5 Henry are connected in series with a battery of 20 volts. Find the current in a circuit as a function of t. Find the current in a circuit as a function of t. Okay. So read your problem statement carefully and accordingly you can directly write down your differential equation. There are only three differential equations: circuit containing L and R and C and L and C. So resistance of 100 ohm. So R is given. R is equal to 100. Inductance, so for inductance, my notation is L. So L is 0.5. Connected in a series with a battery of 20 volts. So voltage is given as 20. Okay, so resistance, so notation is R, inductance means L, and voltage is given. So voltage, battery voltage, electromotive force E is equal to 20. So can anyone tell me the suitable differential equation? You know three types of differential equation. You have to select the suitable differential equation and just find out its solution.
And LR circuit.
Yes, it's a LR circuit, first circuit. So write down the differential equation. So suitable differential equation is L di by dt plus Ri is equal to Q. The circuit containing L and R. Differential equation is L di by dt plus Ri is equal to E. So replace values. L is 0.5 di by dt, R is equal to 100I, and E is equal to 20. So your differential equation is ready, and you can see that yes, it is linear in I. Which is linear in. Okay. So in linear differential equation, we want coefficient of derivative as 1. Here coefficient is 0.5. So to write down the standard form, divide throughout by 0.5. So then we get our standard form. Di by dt plus 100 divided by 0.5I is equal to 20 divided by 0.5. Why? Because if my differential equation is linear in y, my differential equation is dy by dx plus py is equal to q. So you can see it. Coefficient of derivative is 1. Here coefficient is not 1. So divide throughout by 0.5. Okay. So after simplifying, we get di by dt plus 100 divided by 0.5. So using calci also, or you can directly find out, it is 200I plus it's 40. Okay, which is linear in I. Okay. So write down P and Q standard steps. So here P is equal to 200. Q is equal to your right hand side function 40. Okay. So standard steps to solve linear differential equation, integrating factor is e raised to integration p. Now di by dt, integration is with respect to, derivative is with respect to t. So integration is also with respect to t. You have to remember only the standard steps. You can solve any example. So p is 200 dt. So 200 is constant. Integration of dt is t. So my integrating factor is e raised to 200 t. Okay. So can anyone tell me the formula to write down the general solution? If it is linear in y, if it is linear in y, what is general solution? General solution is y into I. Y into I is equal to integration of q into I. Okay, this differential equation is linear in I. So can anyone tell me what is the general solution? Left hand side, integrating factor is capital I. If it is linear in y into integrating factor. It is linear in I, so what is general solution? Anyone? Just unmute yourself and tell me the left hand side. General solution of this linear differential equation. Okay. Linear in y, dy by dx plus py is equal to q. This differential equation is linear in y. Linear in y means my general solution is given by y into integrating factor. Okay, dx by dy plus px is equal to q. This is linear in x. So my general solution is x into integrating factor. Okay, now this differential equation this differential equation is linear in small I. So what is general solution? General solution is, it's very simple. If it is linear in y, y into integrating factor. Linear in x, x into integrating factor. Here linear in I. So general solution is I into integrating factor is equal to integration of q into integrating factor dt plus c. So I integrating factor is e raised to 200t is equal to integration of q is 40. Integrating factor is e raised to 200t dt plus c. Okay, so just simplify. E raised to 200t integration of e raised to 200t dt plus c. So 40. What is integration of e raised to 200t dt? Integration of e raised to 80 dt is same as e raised to 80 divided by a. So use this formula. Integration of e raised to 200t is e raised to 200t divided by 200 plus c. So left hand side is I e raised to 200t 40 divided by 200 e raised to 200t plus c. I want I, so divide throughout by e raised to 200t. So I is equal to, simplifying, we get 1 by 5. If you divide throughout by e raised to 200t, so this is my solution. We want current as a function of t. This is just the solution of linear differential equation, which is linear in I. Instead of our y, here notation is variable is I. So just revise how to solve linear differential equation in y. Similarly, here you have to solve this linear differential equation in I. Carefully write down your P and Q and use your standard steps, integrating factor and general solution. Okay. Now last part is remaining to find integrating constant. Okay. Initially, when time is equal to 0, current is always 0. So replace these values. E raised to 0. E raised to 0, any non-zero number raised to 0 is always 1. Okay, so C is equal to minus 1 by 5. So I is equal to 1 by 5. C is minus 1 by 5. E raised to minus 200. T. We can take 1 by 5 common. 1 minus e raised to minus 200. This is your final solution. So here to solve the problems based on electric circuit, okay, read your problem statement carefully, okay, and using suitable electric circuit. Here this is the circuit containing L and R. So select this differential equation, write down here, replace values of L, R and E. This is always a linear, okay, and instead of y here variable is I. So you know how to solve the linear differential equation in y. Similarly, here you have to solve this linear differential equation in I. Find out integrating factor and the general solution. Okay. So एग्जाम में आपको कौन सा भी इलेक्ट्रिक सर्किट आ सकता है. So you have to remember these three equations, okay, and solve accordingly. If it is linear in I, LR circuit linear in I, RC circuit linear in Q. Okay, this is linear in I. So accordingly solve your electric circuit. So electric circuit, this topic is covered. I'm writing here either you have to use L di by dt plus Ri is equal to E, which is linear in I, or L di by dt circuit containing L and Q. So Q by C is equal to E. After removing, in this case, take E as 0 and circuit containing R and C. So across I, it's Ri. Across capacitance is Q by C is equal to E. But there is no derivative. So this is not a differential equation. So for this RC circuit, replace I by dQ by dt. So you have to remember this, and LR circuit, use this differential equation. LC circuit, use this differential equation. RC circuit, use this differential equation. All are linear. So linear in I or linear in Q. Solve your differential equation. Okay. Problems based on electric circuit. Okay. Understood everyone? Any doubt? So last application, mixing problem. Simple, very, very simple application. Okay, so mixing problem. So like Newton's law of cooling, your differential equation is ready, solution is ready. Log of theta minus theta 0 is equal to minus kt plus c. Similarly, for mixing problem, in electric circuit, you have to select the suitable differential equation and find out the solution. But in case of mixing problems, like Newton's law of cooling, you can directly write down your final expression, okay, and write down your solution. So for mixing problems, so there is a tank in which there is some liquid and some salt is dissolved in it. So Q denotes the amount of salt at any time t, okay, and rate of change of salt. So this is the formula, rate of change of salt, that is d theta dq by dt, amount of salt. So Q, amount of salt is denoted by Q. So rate of change of salt dQ by dt is equal to some amount is entering in the tank, at the same time liquid is leaving the tank. Okay, so we want amount of salt at any time t. So remember this formula, flow rate in into salt concentration in minus flow rate out into salt tank salt concentration. Okay, so this is your formula, and to find out tank salt concentration, use this formula Q divided by initial amount of liquid. Since liquid is entering at the same time liquid is leaving the tank, so your amount of liquid is changing. So initial amount of liquid plus flow rate in minus flow rate out into T. So to find out this tank salt concentration, okay, use this formula. So using this formula, you can directly write down your differential equation. Okay, and you can solve your differential equation. Again, here we get a linear differential equation. So just carefully write down this formula. dq by dt, where q is amount of salt at any time t, is flow rate in into salt concentration in minus flow rate out into tank salt concentration. And to find out tank salt concentration, use this formula Q divided by initial amount of liquid plus flow rate in minus flow rate out into T. If you remember this, you can directly write down your differential equation carefully, like Newton's law of cooling. In Newton's law of cooling, you have to prepare carefully table. Similarly, here draw a proper diagram. What is flow rate in, flow rate out, salt concentration. Okay, so carefully draw your diagram, rough diagram. Use this equation and find out your solution. Okay. So write down the example. A tank contains 10,000 liters of brine in which 200 kg of salt is dissolved. Fresh water runs into the tank at the rate of 100 liters per minute. Okay. So first write down the problem statement, read your problem statement 2 to 3 times, and then accordingly draw a rough diagram. Rough diagram, there is a tank which contains 10,000 liter of brine, okay, liquid, and amount of salt is 200 kg. Salt is dissolved in your tank. Fresh water. What do you mean by fresh water? Fresh water means fresh water runs into the tank at the rate of 100 liters per minute. Fresh water means salt concentration. There is no salt. So in fresh water means salt concentration is 0. Okay, and 100 liter per minute. So this is flow rate is given. Flow rate in is 100 liter per minute. Okay, water is fresh water is entering into the tank. Fresh water means salt concentration is 0. Okay, and inside tank already there is 10,000 liter of water with amount of salt is 200 kg. Then runs out at the same rate. So water is leaving from the tank at the same rate. So flow rate in is same as flow rate out. So flow rate out is again 100 liter per minute. Okay. So draw a rough diagram. Fresh water में salt concentration is 0. So how to write down the differential equation? So what is differential equation? dq by dt. Okay. Flow rate in. So flow rate in is 100 liter per minute. Salt concentration in. So salt concentration, since it is a fresh water, salt concentration is 0. So first term is, see your formula, flow rate in and salt concentration in. So since fresh water is entering into the tank, fresh water means salt concentration is 0 and rate is 100 liter per minute. So 100 into 0. Flow rate in into salt concentration is minus, your term is flow rate out. Remember your formula carefully. Flow rate out into tank salt concentration. Tank salt concentration. So what is flow rate out? At the same rate liquid is leaving the tank, so flow rate out is same as flow rate in, so it's 100 into tank salt concentration. So formula is given to find out tank salt concentration. You can easily write down flow rate in, flow rate out, salt concentration in, but to write down the third term, last term, tank salt concentration. Formula is given, which is amount of salt, that is Q at any time t, okay, divided by initial amount of liquid. So initial amount of liquid. So in your formula you have to replace only the values. 10,000 plus flow rate in minus flow rate out. Flow rate in, flow rate out into T. So this is your differential equation. You can revise your formula. Tank problem. Okay. Flow rate in, salt concentration in, flow rate out. You can write down first three terms easily, but to find out tank salt concentration, use this formula Q divided by initial amount of liquid plus flow rate in minus flow rate out into T. So by using this formula, flow rate in is 100. Fresh water, so concentration is 0. Flow rate out 100. Tank salt concentration Q divided by 10,000 plus flow rate in, flow rate out into T. So my differential equation is ready. dq by dt, 100 into 0. So first term is 0 minus 100 into Q divided by 10,000. 100 minus 100 is 0t. Okay, so my differential equation is dq by dt is equal to minus q divided by 100. So you have to solve this differential equation only. Okay, so like Newton's law of cooling, you can solve this mixing problem. Your differential equation, just remember this formula carefully. Write down carefully the differential equation. Here, since this term is 0, you can solve by using variable separable form. dq by q into 100 is equal to minus dt. So integrating both sides, 100 integration of 1 upon q is log q minus t plus c. So this is your solution. To find out integrating constant, you can use initial condition. Okay. Initially, when t is equal to 0, initial amount of salt is 200. Okay. Using initial condition, you can find out the value of C and your final solution. Okay. Here it is given that how long will it be before only 20 kg of salt is left in the tank. So initially, when amount of salt when T is equal to 0, amount of salt is 200. Okay, so using this initial condition, find out your C, and your problem is how long will it be? So find out time when amount of salt is 20 kg. So like Newton's law of cooling, use this initial condition and find out C. Okay, integrating constant. So you can replace T by 0 when T is equal to 0, Q is equal to 200. So 100 log 200 is equal to C. Okay, replace C here, use second condition and find out corresponding value of T. So like Newton's law of cooling, you can solve remaining part. But to solve this example, draw a rough diagram. Okay, draw a rough diagram. Remember this formula. Write down the differential equation. Either you can solve by using variable separable form or by using linear differential equation in Q. Okay, it's very, very simple. Problems based on chemical mixing problems and problems based on Newton's law of cooling. यहाँ पे तो आपको full marks मिलने ही चाहिए. Okay, so again I am writing here mixing problems formula dq by dt. This is summary. Flow rate in salt concentration in you can easily write down these two terms. Flow rate out into Q divided by initial amount of liquid flow rate in minus flow rate out into T. So normally when flow rate in is same as flow rate out, this term becomes 0. Okay, and we get a simple differential equation. So for Newton's law of cooling and mixing problems, remember this differential equation. Okay, and for electric circuit, you have to select one of the differential equation and write down your solution. Okay, so just revise these three applications. So for this exam, you will get exam में आपको ये तीन applications ही है, not rectilinear motion, not heat flow problems, and orthogonal trajectory. Just revise these three applications only. Okay, so I've covered first two units. Okay, ordinary differential equations and applications of ordinary differential equations. Now third part is remaining partial differential equations. Now remaining two sessions will be conducted by Azhar sir. I will make a short video based on partial differential equations and I will upload on Moodle. So revise only those topics जो मैं cover करने वाली हूँ Moodle पे वीडियो में वही आपको cover करना है like unit number 1 and unit number 2. Understood everyone? Any doubt in first two units? Just wait, let me download the attendance.
मैम
Yes.
मैम फर्स्ट लेक्चर की रिकॉर्डिंग मिल सकती है क्या मतलब
हाँ मैं
थोड़ा
अपलोड कर दूंगी नोट्स अलोंग विथ रिकॉर्डिंग कल मैं अपलोड कर दूंगी मूडल पे.
मूडल पे ना
हाँ मूडल.
मैम वो रिमेडियल की ग्रुप पे भी डाला तो चलेगा मैम.
हाँ रेमेडियल के ही मूडल का जो ग्रुप है ना वहाँ पे मैं रिकॉर्डिंग और नोट शेयर करूंगी.
ओके मैम.
अंडरस्टूड एवरीवन? यूनिट नंबर 1 2 अभी क्लियर ही करना है आप सबको CDE. ठीक है, टॉपिक भी कवर हमने रिड्यूस किए हैं और अच्छी तरह से आपको रिवाइज करके आना है. CDE का रिजल्ट 100% ही चाहिए. एटलीस्ट ये जो 2 यूनिट मैंने पढ़ाए वहां पे आपको फुल मार्क्स आने चाहिए. ओके, थैंक यू एवरीवन.
Thank you.
Thank you, ma'am.
थैंक यू मैम.
Thank you, ma'am.